Well, buckle up, boys and girls, because we have all of these illustrious amplifiers to go through. And I have a feeling that a few of them are going to come away from here and go to you.
Undercover on the beach, you're twerking.
Wayback Machine, and we're going to fly back in time to about 5 years ago when Mr. X was the man. We didn't know he was privately funding and running all these hate groups on Facebook, all these wonderful groups that we've all come to know and love and enjoy today. But we fast forward to today's date and he is no longer with us. Talking about the guy that made blue labeled Xforces. So, gentlemen, we got ourselves a straight 6-pill with Toshibas in it. The thing that we have to evaluate was it originally a PP100 box that somebody put Toshibas into it and then didn't bother to convert it over. We know for a fact that these transistors have gotten incredibly hot and are used, but I don't think they got incredibly hot in this amplifier. Let me explain to you why. Because of the amount of flux that's around the transistors versus the solder work versus the heat damage that would normally be associated with the black shmoo, the flux. We don't have any heat damage to the board. But we can clearly see we've got a smoke 10 ohmer, one on its way, and then another smoke 10 ohm resistor here. So there's one transistor dead in every single section. And it's got way too small a capacitors back here. These will never hold. If you tried to run this, they might last a month or two. Then the caps will fail from heat and then they will burn up, throwing that section out of balance and then causing the whole amplifier to eventually die. I do have some pluses here. This is before they ran out of the metal clads, which is a good thing. So we do have some good parts there. The power supply setup is the same power supply setup that they've had in here forever. And this guy sent these couple of amps up here. He bought them because they had Toshibas in them and he wanted to rip the Toshibas out of these and make this work. And I said, well, before we go down that hole, the dream stella of that hole, let's take a quick look and see what we've actually got to work with. So, give me just a second. I'm going to get in here. I'm going to G.I. Joe this. I'm going to get out the dental pick of death, the crevice tool of all crevice tools, and we're going to flick the solder and see if we can get these to come out of there. And let's test and see what we actually have for product. And away we go. Let's see what we got. So we already pulled the 150 caps out. These woefully inadequate 150 puff capacitors. We removed them from the situation and they're sitting here on the paper towel. Also what we have here are our 10 ohm resistors. Now here's the front top side of the 10 ohm resistor that is in question. Now if we roll over the 10 ohm resistor, we can very clearly see that the 10 ohm resistor is now garbage. And that's a garbagier. So, survey says, what does the survey say? This one has a gain of 29. 29. B29. B29. Survey says, this one is B0. This is junk. So, garbage. This is the next one that should be working. 41. I. NGO, BINGO. 41. These transistors are rough. I'd have to go soak them for a half hour to get them cleaned up. Junk. No component detected. .46. Pretty high gain transistor for as garbage as it looks. How much do we want to bet this one's bad? Gain is junk. Diode junction. Okay. It's not enough to quite say bingo, but the point be proven. Every other one of these has tested out to be faulty. All of them are fairly high gains, 20 and above. That's fairly decent. So for us to make this work, I could technically pair these two transistors together, because they're both in the 40s, these two transistors. This one being down in the 20s is all by itself. So what I need to do is maybe find two transistors that are the same, and then two more transistors that are the same, and put them in here. And then pair these two together, and then put this one in the bone pile someplace for something else that's got a gain of 29. That's the only way we'll make this work with the supplies that have been donated to the fight here, the fight on transistor awareness. So, or the fight for transistor awareness, and not against, for transistor awareness. Like I said, we already went through all of this over here. Got our pill pockets kind of cleaned up. We redid all of our pill strips and got this all looking pretty again. We replaced all of these output capacitors, and depending on what the customer wants to do, we're going to replace these ferrites. We're going to give it a power wire upgrade. We're going to rebuild our combiner network with real, not Chinesium resistors. Put real flybacks in it. We went ahead and adjusted our input capacitors because this was originally a DEI box at some point or another that somebody just literally dropped in 2879s and didn't recompensate for the tune. So, tomato. We're going to make this work. Let me call the customer and we shall return. Okay, so what we've done is he decided he wants to donate the 350 to the cause. He wants me to take this toolbox amplifier, which is made by a nice guy by the name of Toolbox. He's out of Indiana. And I popped the pills out of this real quick. So this is now pillless, this is pillless. We're going to rewash these boxes. We're going to go through all three of these, and we're going to kick them back to you guys here eventually. But for the moment, we're going to focus down on the 6-pill. So we've got two really high gain Toshibas here. And now these, you got to remember, they're in a push-pull configuration, both of these sets. So this is his match partner. This has got a gain of 26, which is still very healthy. Technically, we could run it with this used one. I'll probably end up sending this used one back with this amp, so he's got a spare. Because these transistors are getting a little hard to find. Let's come back down here in a field of view. This has got a gain of 20. So these two are going to get paired together. And Let's test this one here. Now, contrary to popular belief, urban legend, yes, if you sleep with your mouth open, statistically, there's no chance you're ever going to eat a spider. This has got a gain of 26 to it. They got the print wrong on this one. I looked real hard at this. These are legit Toshibas. I looked real hard, but the print's a little off on this one. He wants to build the best of the best with an Xforce, and I said, okay, we'll help you do that. So it's got a gain of 33. A little bit high, but these will work okay together. So we've got 4 fairly close matched gain, or 6 fairly close gain matched transistors that will straighten up, clean out, and we'll drop back in here. I've already gone ahead and replaced all the 10 ohm resistors. So when we cut back, these 6 transistors will be back in this hole. We'll have upgraded to 5-watt flybacks. The power wires will be installed, and we'll be adding sideband to this. Well, we'll get the transistors in here, and then I've got to punch this out. You know, I've said this in about a dozen videos. If he would have just used a little bit bigger waffle stomp pattern to this, or just a little bit smaller, there would have been more velocity present here. There's just something about this resonance size of the fan guard here. So what we're going to do is we'll get out the hydraulic punch, and we'll punch this out, and then we'll put a regular standard fan guard on here, which will allow him to have 3-4 times the amount of airflow through the cabinet, which will give these incredibly expensive components the best chance they'll ever have of surviving. This is kind of a shit design overall. If we were to do anything, I would want to see these rotated this direction, the whole transistor pack turned. So we're heating up the whole heatsink and not just a couple of the fins, but we're going to make do. This is actually an 8-pill cabinet. 1, 2, 3, 4, 5, 6, 7, 8 pills. But we are going to make it sideband capable. Right now it is a Class C amplifier that is sideband delayed. It's got the delay relay, or the capacitor right here for the relay. We're going to make it so it's actually legit Class B, or unless you choose to run it at FM, then you can achieve AB1, so it's actually Class B. We'll make this a legit Class B amplifier. So, okay, let's put some pills in some holes, and let's get the pill holes all filled up so there's no way any metal can get popped in there from over here when we do the fan, and let's get all this neatened up a little bit. Well, I got 10% left on this battery. Let's see how far we can get before the battery decides it's going to die. So, there we go. Let's see. Where we left off, this thing was completely blank. It's 100% populated now. I got on the phone last night, started talking with my buddy Zane, and before I knew it, this whole thing was done. So now we're just playing catch up. This is fully tested. And what I mean by that is I've already run it. This thing produces about 1,700 watts of power, this little 6-pill. So what we did is it's a little bit more busy in here, but it's all for good. This is our sideband relay, and this is what drives our biasing circuit. These are our load resistors. Over here are our clamping diodes. We upgraded to metal clads on the output. We replaced the output network with 5-watt resistors. We went and replaced the singular disc capacitor, and we replaced it with a tuning tube so we can get exact tuning on what we need for output capacitance. And we changed this capacitor, and this capacitor so that they would come away from the DEI setup that was originally intended and bring it back closer to a 2879 form of tune, and it's all working great. I had to replace the transistor in the keying, or in the preamp over here in the corner. He said to me last night, just make sure I got a really good working preamp. And I said, yes sir, you got it, I'm on it. So we made sure to get that done. The other thing we did was this. Let's turn the cabinet around. We got rid of all the air restriction in the back. I had to pull all the power supplies out of this thing and slide them all the way forward so we could get the hydraulic press in there. And we punched out the grill, replaced it with this fan guard, so now we've got direct airflow going in unimpinged. So after talking with him on the phone today, Mr. S wants me to go ahead. He says, is there anything else we can do to it? And I said, well, we might be able to add one more fan, maybe get a little bit more air, be able to come out the exhaust port. More air, more better. Heating with this style of amplifier has always been an issue. So he doesn't have to be like a 2-second wonder on the key, and doesn't constantly have to have his finger back here feeling heat. We're going to go ahead and we're going to relieve the lid. There's a waffle pattern here. We could put a fan behind this, but it'd actually make the fan louder, and it's going to really restrict the airflow. As much as I like this pattern, don't get me wrong, but we've discussed this many times about how this actually ends up restricting airflow. So let's get that started, and then when we come back, we'll be punching the lid out. We'll get the fan installed, which will be an AC fan, by the way, and then we're going to show you the final end of this thing. He did actually purchase a driver from me today for this, which I think is going to be awesome for him, and we'll show that off here in a minute too. Shall return, and we did it before the battery died. So this is a 4-inch die, and the waffle pattern for this is cut for like 122 millimeters or something. So it's never perfectly perfect. There's always a little bit of the hole puncture perforation left over. So to try and make it look pretty-ish, I really take the time. I over drill the hole for the cylinder on this thing so I can slide the die around and make it just sit perfect. So I try to aim the die so we're right in the middle where we start our cut, and we're going to pull this in, so the die is going to go down. And the reason we want to do that is we want to fold our edges in, and that way there's no rough edge. But there are going to be a couple of these holes left over. I don't like that, but I'm not the one that punched the case. I remember before I had a 4-inch circular saw that I used for this, and I hated punching holes in cabinets because it was like it would always come out a little ragged. You know what I'm saying? So what I ended up doing is I went over to Harbor Freight, and they've got themselves for like 50 bucks a hydraulic cylinder kit for punching holes. Well, then I got on the internet and I bought myself this Greenlee punch, and all the other subsequent dies that I bought are all Greenlee based, but the thread pitches are all the same. So the hydraulic ram that makes this possible is a Chinesium component, but it's all based off of American technology per se. So you very carefully remove that, and it doesn't look like a tweaker did it. Because I get these in here all the time, and it's like a tweaker takes and tries to cut a straight edge and another straight edge and another straight edge, and it just looks horrible. I mean, it looks horrid. I mean, horrid. I call it the gack attack, man. Some tweaker got gacked out and they thought they'd try and make their airflow better, but it just, I mean, visually aesthetics, it just looks horrible. Yes, this is the punch that took the end of my finger off, and I used to love this thing. I'm like, ooh, I'm gonna punch shit and everything, punch holes and everything. But that is the end result of this. A perfectly clean, beautifully cut hole. That couldn't have come out more perfect. That looks good. That looks good. Well, I went ahead and I set this up so the lead for the fan is like silly long. So if you need to, you can take the cabinet off and work on it if you need to, but I don't think you're ever going to need to go back in here. I'm done in here. I've run this thing already. I know how this is going to work, so let's put the lid on it. Let's put some screws in it. And let's see how loud it is with the fan. Adding that fan is going to really add life to this box. This particular cabinet design, like I have said several times now, doesn't really lend itself to the best cooling. So, and I put a big 110 volt, double thick, I guess it'd be like 20 millimeters thick or whatever it is, sun on 110 volt fan in here, which is going to move more air than the fan in the back. So I think you're going to get more airflow from this fan than what you're going to get from this fan in the back, but still you want to leave this one open. I've never liked having a fan in the back of the cabinet pushing air in, because there's this phenomenon called recirculation, which sucks. And what that means is, as the amp is exhausting the heat out of the back of it, it has a tendency to flow out and then get sucked right back in, because people put this on a shelf up next to a wall. So hot air comes out, it's getting sucked right back in the fan. So you have a lot of recirculation heating going on, which is dangerous. So when you said you were open to putting another fan in there, I was like, my man, make me happy. So I have this plugged into a 15 amp 110 volt outlet down here underneath the bench. There's nothing else hooked into it. And the reason I test like this is for what we consider to be ideal situations, an ideal circumstance. Okay, there's no current drop going to the fan, no voltage drop, and we want to maintain our best possible chances for success. So let's go ahead and let's run this thing here in a second. Let's get our units of measure all done up here. It'll be a 1,000 watt slug in peak, 1,000 in average, and a 5 watt slug in reverse. So let's go ahead and kick this on. It's pretty quiet. I mean, ain't nobody gonna lose no hearing over that. I can guarantee you that. But man, this thing is moving some air out of this vent in the back, which you'll feel when you get it. Just pulling it in there pretty good. I'll have a lot of blow-by on this fan in the back here, but good airflow coming out of the vent in the corner. So let's run this a little bit. So first, let's make sure that this thing is in standby. It's your preamp switch, operate standby. So let's put that in standby for right now. Now we're going to hit this. We're going to hit this with our Striker 490 or 1X. Hello. Hello. We're going to swing about 100 watts into it. Hello. Oh, wait a minute. Blue. There we go. It's gone. Hello. Audio. Disappearing off the scale. Let's tighten on up in here a little bit. Hello. Gone. Okay. So now we'll go ahead and we'll go up to 2X. So now when the needle goes fully to the right, it's 2,000 watts. Hello. Audio. 1, 2, 1, 2. Okay, now the bench power is down here on 12 volts. So let's go ahead, we'll turn this up a little bit. We'll let the supercapacitors charge all the way up. Now, let's come back down to 1X. Put this in standby. Wind up a little bit so you can see we're in standby. Hello, audio. Now we come way up on output power. Hello, about 150, 160 watts. I'll put this into operate. Flip that down to 2x. Hello. Oh, I put us in 5. My bad. Let's go to 2. Hello. Audio. About 1650 to almost 1700 watts. So now we'll turn our power supply back down. And it's moving there. Let's go ahead, and I'm going to pull off here for a second. Let's put this thing in standby. Let's go ahead and switch over to the last test. Preamp is working. And what just clicked in my mind is I've got an operate standby switch, but I don't have an SSB switch. But then we have an SS delay cap in the bag. Biased it for sideband, never bothered to see if the switch was there because I seen the capacitor hooked up in the bag. All right, anyhow, we'll come back to that. I'll fix that here before it leaves. This is your little 1-pill 2879 Toshiba that you bought as a driver. It's got this big old fan on top of it. Now, this little 1-pill can do some impressive things. Right now we're currently at about 13 volts flat. Let's go on in here and let's take a look and see what we got going on. So, the big amp in standby. Now I've got this backed way down, the radio, because I know how you said you're going to run it, like 1 watt swinging to about 11. So, let's take our 5 watt slug that's normally in reverse and make it read forward. Putting 1 watt in it, hello audio. And what we got to do is look at this now. Hello audio. Got it swinging to about 10 watts. Okay, now let's bring the 1-pill in with the variable all the way open. Oh, turn my 5 watt slug around so I'm not going to murder it here in a second. Hello audio. Hello audio. So 1 watt going to 10 gets us about 10 watt carrier going in, making about 115 watts coming out. Now we bring the big amp on. That's a 500 watt carrier. So we can't run it like that. You're going to end up murdering your amp. It's going to get real hot real quick. So back our variable down. We'll get this down around about 250 watts or so. Hello audio 1 2. Still goes way off the chart. Let's click that up to 2x. Hello audio. Now let me show it with you with the variable all the way open. Hello. Hello. It's going over the 1700 watt mark, but it's coming back. Now if I was to open up the mic gain a little bit. Hello. Hello. Everything's still swinging forward. Hello. About 700 bird-ish, give or take. Hello. Hello. Now I'm having to really keep this 1-pill underneath restraint. The reason I say that is because we're down here at, 12 volts now. So if I reach down here, I turn this on, I'll say I'll run this safely at 14.5 volts. Hello. We're definitely going over, but we're pushing our very expensive Toshibas. Is it worth it for an extra 100 watts? Absolutely not. Hello. What has that done to our output power? Well, let's take ourselves a look. So now we're back down in 1x. And we're just on the driver. Remember, we're making about 110 watts before, right? Hello. Brought us up a little bit. But Be careful. Be so careful. Oh, 1, 2, 150, 160 watts. Be careful. Now, I set this up all per to your instructions, Mr. S. This amp I had turned way up and had it making a whole lot more power than what it was. But I knew if I sent this to you like that, it was going to end up killing this. There's a lot of damn money wrapped up in this amp as far as transistors go. If you get 15, 1600 watts out of this, be happy and just run it. And it'll last you a lifetime. Take it easy with this. I know the radio that you're going to use, just take it easy. It's got the sideband delay switch here. Well, I guess before we wrap this puppy up, what's the point of putting sideband in it with no sideband delay? That could become very disconcerting. So, once again, let's pull the one pill out of line and get my workbench space back. Let's get that tin off there, and if I guess I got to drill another hole in the front and add a third, fourth switch for sideband, it must be done. It must be done. Oh, this is exhausting. Look at this. So we got the extra red and black wires. Where they come out over here. And here's the sideband delay capacitor. Right down in there. They've got half the cap hooked to ground, which you can't see. Let me move the camera around. I get this out of shadow and it'll let it focus. We got half the cap soldered to ground, and then the red and black wires for that switch are tied onto the positive side of the cap. What? Okay, so let me rip out the sideband bias relay. We're going to take this out. We'll disconnect that cap. We'll flip it around. We're going to hook the ground up to here on this point right here on the primary keying relay to help hold that relay open and closed longer. And then we'll grab up the red wire. We're going to attach it to here over on the positive rail. And then we'll hook up the black wire to the positive lead here on the capacitor. And then we'll tie the red and the white wire together, or the red and the black wire up here with an on-off switch. It allows us to control the delay. Oh, what the hell? Man, what the hell? So, we added the sideband switch, which we'll put a label on it here in a second. So, what we're going to watch is the relay armature. So we're on sideband. Hello, 1, 2, 1, 2, 1, 2, 1, 2. You see it jumping? Bring the sideband delay on. Hello, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Which is perfect. Hello, 1, 2. Hello, 1, 2, 1, 2, 1, 2. Now we're just hitting this with the 955, and the whole point is just to demonstrate the delay is working. So we got our delay all lined out, got our switch installed and got all that wired up. I can't believe I let that slip on by my century of perceptions, but let's button this thing up. It's time to come to an end. This thing is about as done as it's ever gonna get. Son of a gun. Okay. Let's see here. SSB. Print. Printed it. Did it wad it all? Oh, it wadded it all up. Son of a fart snatch. Okay. Take 2. I love this thing. I love this printer. I've had it for almost a decade. It's got a million fonts in it. You don't have to read a manual and memorize no submenus or nothing. Love it. This thing is easy to use. Full up retard like myself can use it easily. All right, let's grab a scrub. Let's go just like this. Nope. Oh, ah. Okay. Little SS delay with sideband and the whole 9 yards, bias and the whole 9 yards. It'll actually do everything it's supposed to do now and not murder the pills. Well, Mr. S, you're done, man. Brought back from the grave, all cleaned up, looks pretty on the inside. Feel free to open the tin up and look on the inside. Whatever you do, don't mess around with that output tuning tube. Leave it alone. It's dialed in specifically where it needs to be. Moving that tube will not help you get any more watts, I guarantee you. Leave it alone. Leave it alone. Well, that's it. That's the end of this song and dance with this particular box. I took those other couple in on trade, so as soon as we finish up with that, let's go hop onto one of them and get 2 or 3 of those things fixed. So there's a little bit of Texas Star in here, a little bit of Xforce in here, a little bit of train built, or pardon me, toolbox built, pieces and parts from all them things, all wrapped up on the inside of a Xforce straight 6. It has now been completely rebuilt by me. Gentlemen, my name is BBI. Without a shadow of a doubt, I am the biggest mud duck in Idaho. I appreciate every single one of you guys tuning in and following along. If you haven't bothered to subscribe yet, please do. Give me a thumbs up. It helps the channel out tremendously, the more thumbs up I get. I appreciate you guys. I thank everybody for their patience and how long it takes me to get to things. I know this is an issue, but there's nothing I can do about it. I'm a one-man band. I appreciate every single one of you guys. I'll see you. Click, click, click.